Okay, so in the last week, we were trying to understand the concept of microcontrollers. As I had mentioned during the introductory part, microcontrollers are the heart and soul of almost all electronic systems that you see in and around you. The micro, I mean, from the mobile phones that you use to the washing machines, to the watches that you have, and even the Mitsis or whatever electronic equipments that you have in and around you will have a microcontroller. So microcontroller forms the base of any mini project or the main project that you do. Microcontroller is more, is more familiar or can be more used compared to a microprocessor when it comes to building a product. But when it comes to doing processing at a very high degree, we use microprocessor. So you should be aware that inside your washing machine, which is an embedded system, there is a microcontroller which is running. And the microcontroller, as you can see, not only if you speak about microprocessor, the only thing that a microprocessor does is take the data from a memory, process it, give it output. It doesn't deal with direct physical world. If you want such kind of an activity, you need additional ICs, peripheral ICs, then other ICs to control. So it's very difficult to implement systems based on microprocessors, whereas microprocessor is very good at processing things. If you want some signals to be processed, if you want some mathematical high-end multiply and accumulate operations to be done, you go for the microprocessor. So in your mobile phones and all, and almost high-end processing things, you will have a microprocessor. Along with that, you will also have a microcontroller which will deal with the mundane work of controlling things. Okay, so that's the idea of your microcontroller and your processor. So we had started off with 8051 as your basic microcontroller. We started off with 8085 as your basic microprocessor. Similarly, in the case of microcontroller, we start with 8051, both from Intel, and you have lots of microcontrollers based on this 8051. It's called as MCS 51 microcontroller family. Not only 8051, 8035, 8351 or something. There are different numbers or different companies which comes out with 8051 based microcontrollers with small modifications in the internal circuitry or internal blocks. So Atmel, then your microchip, then Della Semiconductors, then Texas Instruments, lots of companies comes out with 8051 based microcontroller. 8051 was one of the first microcontrollers which came into existence. It was called as a system on chip at the starting level, or you could integrate everything that is required for a system onto a chip. That was the idea of your 8051 or microcontroller. We have already given the pin configurations of your 8051 microcontroller, Intel's 8051 microcontroller, the ports we have studied. So if you want something to interact with the outside world, if you want a system or a product to interact with the outside world, you need to take inputs, you need to produce outputs. If you look into the washing machine, the activities which are happening inside your washing machine, you have a drum which rotates, you have a display which will show you the details of your particular thing. Then your rotation of your drum, which is controlled by a motor, will be based on the inputs that you give using your switches or using your options on the display. Then according to that, the drum moves in different directions at different speeds. So you need somebody to take all these inputs through the user, then convert that into an output which can be generated and which can produce these kinds of motor based signal. So you require inputs and outputs for ports to do that. Simply memory will not be sufficient, or simply interfacing it to the memory will not be sufficient. Has this connection gone off? One second. Everything fine, right?
Yes, sir.
Okay, fine. So okay. So we were speaking about such kind of microcontroller. So one example for this is 8051. Try to comprehend it, try to understand it at the application level. So microcontroller is used at lots of things, and since you require inputs and outputs, you have lots of ports which are going to be used. As you might have, understood, you will have digital inputs and analog inputs which are taken in. So you need, if you want to control your particular what to say, rotation of the motor, the values has to be taken in. Say if you want, say if you are speaking about an oven, you have temperature readings which are coming in. You will have a temperature sensor which gives us you readings, and based on that temperature sensor values, the oven will perform. You will heat it up or you will slow it down. You will heat the, what to say, heaters which are being used, whatever. So every particular microcontrolling entity requires inputs. Now when you speak about inputs in a technical level, you speak about analog inputs and digital inputs. So your microcontroller should be able to handle analog inputs as well as your digital inputs. Understand that the Arduino board, which is commonly used whole across your particular what is it, mini projects and main projects, is a microcontroller based board. And the microcontroller which is there is, I think, Atmega 352 or something, based on the type of Arduino board that you're using. So microcontrollers forms the basis of most of the systems that you see today. So out of which we are studying one particular microcontroller, that is your 8051. We have already seen the pin configuration of that particular microcontroller, which consists of different ports, which consist of mainly the ports, and the ports will have different purposes to it. It can act as input or an output port. It can act as address bar data buses when you have memory interface to it. It can act as transmit and receive pins. It can act as something associated with interrupts. So mainly when you speak about a microcontroller, the most common word or the most common pin which you can see in a microcontroller will be the port based pins. And in your microcontroller 8051, you're having 4 ports: port 0, port 1, port 2, port 3. All are bidirectional ports, with certain ports being used for more than one purposes. Certain ports or one port being used only for bidirectional data transfer. So accordingly, we have seen the pinout. We have already seen the features, then moved on to the pinout. So this is the pinout of 8051. As you can see, lots of ports are there, and the port 1 is the most simplest port, as it functions only as a port. It only functions as a port. It has bidirectional data coming in and coming out. Data basically means your digital values. Unless it is specified as analog values, it can take only digital values. So again, so you have ports which are being used for this. Then you have your port 0 being used as a simple bidirectional port, as well as AD. AD is basically when it is interfaced to a memory, this will use this will be working as a address bar data bus, which is what you have seen as part of your 8085. Similarly, your port 2 can also act as your address bus. The higher order address lines will be there. So this is the purpose of your port 0 and port 2. Two functionalities being performed with the port. One is the usual bidirectional input output port. Second one is it is acting as a address line, or in the case of port 2, address lines, address bar data lines, and address lines, depending upon if you have an interface, external memory interface to it. Then you also have the port 3, which is again lots of functions. Each pin has different functions. If you can see, port 3.0 to 3.7 has different, each of these pins have different functions: receive, transmit, interrupt, timer, write, read. All these are associated with port 3. So on except port 1, all the other ports can have more than one task or more than one function. Keep that in mind. Other than that, you have very minimal signals like EA, which comes into picture when you have external access or external memory getting interface to it. Program, you need to program your 8051. For that, we use this one. ALE is your address latch enabled. PSN, again associated with your external memory. Prob select enabled. Just go through the definition of PSN, but that is something which is we will see that when you speak about interfacing. Okay, so other than that, crystal, ground, and VCC. So these are the pinouts of 8051. Very easy to write pinout. So make sure that you learn 8051 pinout. So today we will speak about the architecture and how the microcontroller inside it, or the blocks inside the microcontroller works. So when you speak about the architecture, you can see three types of architecture diagrams. This is the most standard architecture diagram taken from the data sheets of MCS 51 microcontroller, which gives you an expanded version of how a microcontroller is. Now you also have, if you just look into your 8051, the textbook that is going to be acting as the base textbook is the textbook Ayala. Hopefully you have seen it. I will just open it up and just make sure that you have at least seen the cover page of your textbook. Okay, 1 second. So I have already shared you the textbook. So make sure that you go through the textbook. Try to read the textbook. Always keeping on telling it. It is required for the understanding of stuff. Okay, so I'll just share these 8051. Okay, so are you able to see it? Can anybody respond to the mic?
Yes, sir.
Yes, sir.
Okay, so you are able to see the 8051 microcontroller textbook from Ayala. So if you go into the what is it, this thing? Okay, so inside this you will have all these things, and you will have a, if you are not this thing, architecture. So you will have an architecture diagram of your 8051 in page 11 is what is being mentioned. Let's see if it's there in page 11. Sorry, it's not there in page 11. Let's move along. So this is the block diagram which is being, or the architecture which is being shown as part of your 8051 textbook. The same diagram in a more expanded way is what we are trying to explain. So you have another option also. If you check into the internet, you will have a more simplified version of 8051 architecture available. But if you want to score the maximum marks, if you want to explain each blocks and to get a very elaborated diagram, you have to follow the diagram which is shown as your in your slides. But you have the option of moving into the other diagrams as well, according to your memory capacity, according to the capacity that you can store data. You can use any one of the diagrams. Not each of these diagrams are correct, but when you go into the net, you will have a more smaller diagram with smaller number of blocks. This has a more expanded diagram, your Ayala textbook, but the diagram that is going to be used as part of your presentation will be the most concise, most precise diagram available. So I will be focusing on this diagram as the architecture diagram. When you ask about block diagram or architecture diagram, you'll have to draw this particular diagram and then explain it. 1 second, I will just share the slides once again. Okay, so this is the architecture diagram of your are you able to see this slide?
Yes, sir.
Okay, so this is the architecture diagram of your 8051. Now they have shown outside the diagram, you can see your VCC and VSS, the the pins which are connected, the ports which are connected, port 0, port 2, port 3 and port 1. So the pins are given out here, each of the pins. 1 second, I will just take the laser pointer. Okay, so you have the ports here, port 0, port 2, port 3 and port 1, and then you have your VCC and ground being connected. So this dotted line is the IC, and everything outside it will be the pins. Now then you have your PSEN, the ALE, the EA and reset pin connected to the timing and control and the instruction register block. Then you have an oscillator which is there inside it, but the crystal has to be supplied from the external source. So be aware that you have an oscillator, but the oscillator, if you have done any analog experiments, you know that oscillator works with the help of the frequency of the oscillator is determined by the crystal that is connected at the outside. So the crystal is connected externally. So these are external connections, and you will have a capacitor to avoid the noises which are associated with it. To get a constant frequency, we will be using this particular thing. And here the oscillator is basically divided by 2 counter, so the whatever the frequency that is given is divided by 2. We'll see that later, but this is how the oscillator or the clock generating circuit of it works. So you have to connect the external thing even though you have an oscillator here. So a crystal has to be supplied externally. If you look into any particular, I will show you the Arduino board at one point of time. So you will have a particular silver kind of string with a particular frequency written on it. That is basically the crystal oscillator which is being used. Almost all boards will have such kind of an oscillator which will be connected to, that's kind of a crystal, that means ceramic crystal, which will be connected to the oscillator which is there inside it. Okay, so that will be associated with the timing and control. So the external pins are being mentioned here. Now we will move on to the internals of this particular diagram. Now you are aware, inside this you see that you have two kinds of buses. One is your data bus, which is of 8 bit, and the other one is your address bus. But most of the things are attached to the data bus. Okay, now we will start from the ports. What are the ports which are being, so this is the oscillator block which creates the timing circuit which is connected to the timing and control. This is basically the brain of your particular system which works according to the signals which are received. So inside that you will have the instruction register where the instruction is stored. You have IR register where the instruction is stored. The currently executing instruction will be stored inside it. This doesn't support pipelining, so a single instruction will be present in this particular instruction register. And the timing and control register is the register which is associated with controlling all the timing activities inside this particular block. So you will have connections from timing and control to different blocks through this channel, and even other connections controlling signals which are not being shown here. So this is associated with everything related to timing and control. If you want to control something, if you want to create time details, this is the block which does it, and it takes input from the 4 additional pins which are there in your particular microcontroller: the PSEN, ALE, EA, and reset. Okay, so hopefully this block is clear to you. The oscillator is basically used to create the crystal frequency. It will require a ceramic crystal to be connected to the external side. The crystal frequency is, I think, from 2.35 to around 11 point something. You have a particular frequency range. The odd number or the 2 point number 11 point is because when you want to go for serial communication, you require a baud rate requirement. In order to get the baud rate correctly, the frequency has to be in a particular format. That is why you will have not 2 megahertz, you will have 2.1, 2.13 megahertz. So that is associated with serial communication. All these things we will study later when you speak about the interfacing. But be just aware of these particular blocks. Now that is with respect to the timing and control block and the oscillator block. Now we will move on to we will move on to the ports block. So as you can see, you have ports being, all these are bidirectional ports. So you have 2 lines which show arrows at the left and right side. So it basically means you can put data outside to the world or take in data inside the world, and each of these ports will be derived. You need enough current and voltage requirements, mainly the current requirements, to drive these values. So that is done by these drivers, which are basically circuits based on transistors and based on additional components which will drive this particular thing. You are already aware of driving circuits and all in your electronic circuit theory. So this is the driving circuit, and in this particular thing is associated with the external world. You can put a value here, you can output a value, but it goes inside to the microcontroller only to the only through the latches. So the latches are basically the memories which interacts with the drives. So you have this particular data from this port 0 going into the this is consider this as the internals of your microcontroller, go into it through the port 0. So if you want to output something into the ports, you will be putting that value into the latch, and then according to the signals given from the timing and control signal, the values will be output. So you can make these particular signals as input or output signals, bidirectional. It can act as input or output ports based on the settings that you have done, and then you can use these latches values, latch registers, which are basically memory elements, which will be putting the values through port 0, port 2, port 1, and port 3. Okay, so as I had mentioned, port 1 is a simple IO port. Then you have your port 3. You have different utilities to these ports. That is being mentioned here. Then port 1 and port 0. And if you go back to the block diagram, as you can see, port 1 is a port which only acts as a bidirectional port. So as you can see, the port 1 is connected to the this is your internal 8-bit data bus, which goes all around this ALU. So you have your ALU being acting as a central entity, and all around it you have your internal data bus. So the port 1 latch is connected to the internal data bus. Port 3 is also connected to internal latch. Port 0, port 2 is also connected to the internal latches, both in the bidirectional format. Additional to this, your port 0 and port 2, which both acts as a AD and address lines, have a connection from your program address register. So this is associated with interacting with the external world. So that is why you have a program address register, which is basically a register which can have 16 data lines, as you can see, and from that you get an 8-bit value. So it is addressed using a 16-bit line, but the output is an 8-bit value, which is going to be written into your EEPROM. We'll see about the memories here. So you have a connection from that to your ports, because this can act as your address buses or data buses when you're trying to interface external memory. Okay, so that is with respect to port 0 and port 2. Port 1, as you can see, it is connected to the internal data bus, and you also have some connections from the interrupt. So that is why it is connected to a block which is associated with 3 things: interrupt handling, serial communication, timer blocks. So you have a box which is associated with it, which has connections both to the port 3 and the port 1. Port 3 is more significant because everything is under the control of this. These pins can be used to control the interrupts. That is why this is being connected to this particular point. But port 3 is the default port in which you have all these blocks being associated. So I hope that the connections of your port 1, port 3, port 2, and port 0 is clear. So you have a latch and a port. So you have latch where you can store things, and you have a port which is physically connected to the outside world. So the data from these ports go inside your microcontroller through these latches. Okay, so all these blocks are over. Now now we will speak about the ALU. We will speak about the memories. Now inside your microcontroller 8051, you have 2 types of memories. So this is on-chip memories. In the case of your 8085, if you look into it, you only have the registers. But other than, inside your 8051, you have more amount of on-chip memories. You have an 128-byte RAM memory, which is given here. This is a 128-byte RAM memory, and it is addressed using a RAM address register bus. So you require only 8-bit. So everything associated with this 8-bit. So there is a connection from RAM address register bus. You will put the address which is required here, and it will give you the address which will be used to access your RAM, and from that you can either write or read using this port. So this is a one-directional port. You write the value, you produce the output of the address of your RAM. So it's a memory, so it requires address and data. So the address comes from here, data is given out here. So the data can either be read or written because it's a read-only memory. So that is why it is given as bidirectional. So this is one type of memory which is used. We will see the what is inside this particular memory. So inside your 8051, you have a RAM memory. It is of size 128 bytes. Each position. That means you can have 128 bytes, which basically means you have 128 locations. Each of these locations are of size 1 byte. So that is why it's called as 128 bytes. So this is used to for temporal storage. You will see the expansion of it in the next slides. So that is one type of memory. Now that is the memory which is used in the real time. When the program is running, if you want to store something, you use this kind of memory. Now where is the program? In the 8085, the program was always outside. But in the case of 8051, the program can be inbuilt into the 8051 using a ROM memory, which is of size 4 kilobytes, or EEPROM. Earlier it was ROM, then it was changed to EEPROM. What is the difference between ROM and EEPROM? ROM is a read-only memory. You store the values inside the ROM, and the values remain as such, and you cannot change it. If you want to change it, you need to change the whole IC itself. So if you have built a program, you put that particular program into the ROM memory, you cannot change it. But if you have EEPROM, you have an possibility of changing it. So you build a robot, you want the robot to move to the left or right or to the sides. You want to again upgrade it to another level, having say upward and downward motion. Then you will have to change the IC if you don't have the EEPROM, if you are having a ROM. But if you are having EEPROM, you can reprogram it according to the signals that is given. So that's the idea here. So the program is situated in this particular thing, and the real time, the executing data is situated in this kind of memory. So we will see this again 4K. Additional to this, since it's 16-bit address lines, it can additionally have a total of 64 kilobytes of memory. So you can either put the 64 kilobytes of memory completely outside your particular microcontroller through these ports, or it can be a combination of some memory outside, 60K outside and 4K inside. All combinations are feasible, and the addressing of this particular memory is done through this RAM address register. This is program address register. This is not ROM address, because it is where the program is stored. So you have your program address register being used to change the values, to get the values. So this is basically a one-way register. So it gives you the address value. From the address value, the data will be obtained. So this is with respect to the memory. You have a ROM memory here, and you have a RAM memory here. So both has a combination of the memory and an address register, which will generate the addresses. The RAM address is generated by the RAM address register. The ROM address or the EEPROM address, which will have the program inside it, is generated by the program address register. So we have learned about the ports. We have learned about the ROM memory. We have learned about the RAM memory. Okay, now timing control and all we have already discussed. Now we'll move on to the internal. So inside your particular 8-bit bus, which is drawn all around your ALU, you have the ALU, which is your arithmetic logic unit, which performs all the arithmetic operations. You have two registers, TEM1 and TEM2, which are not under the control of the user. It is by the microcontroller. According to its requirement, it will be reading values or writing values into your TEM1 and TEM2 register. Both are 8-bit registers being used by the microcontroller to execute instructions inside your ALU. Now you have the accumulator, which is the standard default register, which will act as one particular operand, and also the result will also be stored inside your accumulator. It's a register which is user controlled register, and you can specify what the values should be written, and you can use instructions to load the values into the accumulator. So this forms your ALU, and the output of the ALU is connected to the bus and also to the PSW, program status word, where you have different flags. So depending upon the operation of your ALU, the program status word will change. The carry flag, the auxiliary carry flag, the overflow flag, everything associated with the ALU operation will be affected into the PSW. But we'll learn what the flags are when you be in the configuration of program status word. So this is with respect to the ALU part. Other than that, you have a general purpose register called as register B, again accessible by the instructions by the programmer according to his requirements. He can read and write into your register B. So TEM1 and TEM2, the difference between TEM1 and TEM2 register and register B, the accumulator, or it is called as register A, is that TEM1 and TEM2 is completely under the control of microcontroller. A programmer is not able to access it, whereas accumulator and register B are accessible by the programmer or somebody who is trying to use the microcontroller. Okay, so that is with respect to this. Then you have your stack pointer, is basically used to stack is implemented on the RAM memory, and the stack pointer will have the top of the stack. It's a 8-bit register, which implies that it is implemented in the RAM memory. The default value of it is 07H. We will see the values and memory organization of this particular microcontroller in the next slides. So this is with respect to the port blocks, the memory blocks, the ALU blocks. Now we'll move on to the right hand side, which consists of a buffer, which is basically, it's a 16-bit buffer which is used to save data for the microcontroller to work. It doesn't have any access from the external world. So then another thing, 3 things which are associated here. One is your program counter. Program counter is something which you are aware of, because if you want to run a program, you will have to store, you will have to have the program counter incremented. Program counter will have the value of the address of the instruction which is currently being executed. Program counter incrementer is there, which will increment the program counter value to point to the next instruction to be executed. So it is a dedicated hardware to increment the particular program counter value. It increments it and then again puts it back into the program counter. So the program counter will be used to access your ROM value, which is where your program is situated, or it can be used to access a program which is situated in the external world. So the program counter gives out the value of the currently executing instruction, which will be loaded into your instruction register. Okay, then another pointer that is available is your data pointer. Data pointer is associated again with external interface. If you want to interface externally, you will be using the data pointer, which is again a 16-bit register. 16-bit register will give you will produce the corresponding address required to access something externally connected. So external interface, you will be using your data pointer. So this is basically the block diagram. If you're 8051 architecture, you might have understood certain bits, you might not have understood certain bit. You will be able to completely understand it once you learn this theory of your 8051, then move on to the programming of your 8051. So module 3 is all about the theoretical part of your 8051. So we have already defined the pinout of your 8051. Remember that it has 4 ports: port 0, port 1, port 2, port 3, and port 1, port 2, and port 3, out of which port 1 is a bidirectional port. All the other ports have more than one task to be performed. Okay. So moving along, so we need to understand how the memory is organized. What do you mean by special function based? First, we will speak about the RAM memory. I told you that 128 bytes of RAM is there, which can be accessed inside your 8051. 128 bytes of RAM implies what will be the address range. Since you are having 128 bytes of RAM, the address range will be from 00 to 7F. You can see, you just go through the theory of it, and then you will be able to 128. What is 1? When it is raised to 1, it will be 2, 4, 8, 16, 32, 64, and 128, which implies that you need 7 bits. So accordingly, the memory organized for your particular 128 bytes of RAM starts from 00 to 7Up. So this is how the RAM memory is organized, out of which you have 4 bank registers. Okay, so 4 bank registers. Each of these banks consist of 8 registers. So bank 0, bank 1, bank 2, bank 3. Out of this, 1 bank will be active at a particular moment of time. So these are your general purpose registers. You have 8 into 4, 32 general purpose registers. But this particular register set, or this particular registers, one of these banks will be active at a particular moment of time. So 8051 consists of 4 banks: bank 0, bank 1, bank 2, bank 3. Each of these banks have 8 registers of 8-bit size. Their address starts from 00 to 1F, 00 to 7, 08 to 0F, 10 to 17, 18 to 1F. So this is your set of registers. Now from 20 to 30, you are having a set of registers which are bit addressable. See, this is very important functionality of a microcontroller. It is able to access bits. If you want to control something, if you want to check one particular value, why do we need to check the whole register? We just need to check one particular bit position. in the microprocessor and all, we need to take the value, then avoid the other 7 bits, take only that particular bit. It is tedious. Whereas in the case of microcontroller, which is basically used to implement things which will have bitwise control, you have bit addressable locations, you have instructions which can access 1 bit at a time. And so the address locations from 20 to 30F, 20 to 20F, 2F, 20 to 2F are basically bit addressable, and each of these positions inside this particular bit addressable registers are accessible using these address values 00 to 7F. Okay, so you can use the corresponding instructions if you're using a bit addressable instructions and you're using this value. It understands that the microcontroller understands that you going for a bit based control, and it will take the corresponding value from this set of addresses. So you have the set of registers from 20 to 2F, which is being used as bit addressable locations, and each of these locations have an address range from 00 to 7F. So after that, above that, you have general purpose RAM, which can be used for any purposes for storing of data, 30 to 70F. Are you clear? So this is basically the memory organization. So this comes from this particular part. RAM of this particular diagram is expanded here, consisting of 00 to 7F byte address locations, each address of 8 bits, and is divided into different segments, I mean different parts. At the lower part from 00 to 1F, you're having banks. Each bank consists of 8 registers of 8-bit size, which is going to be used as a during the program. And then you have a set of bit addressable locations. On top of it, you have your general purpose RAM. So this is the organization of your RAM memory. Now, above that, above the 7F condition, above this 7F value, you are already provided with 00 to 7F, 8-bit addressable location. So you have a range from 80 to FF, which is not being utilized. The 80 to FF value, so certain locations in 80 to FF, not all locations, certain locations in 80 to FF are used as special function registers. Okay, so you have having 128 bytes of memory. You are using 8 bits to represent these 128 bytes, and then from the 80 to FF, the locations of these particular 80 to FF, you are having different special function registers. You program your microcontroller mainly using these special function registers. Putting certain values in the special function register, you will get the corresponding expression. Each will have its own definition. So the addresses are given on the left hand side, and what are those registers are given in the right hand side. So you have accumulator register, register B, program status word, interrupt priority register, port 3 register, interrupt enable register, port 2 register, serial buffer, serial control, P1 register, TH1 timer, TH1 and TH0, that is your timer low value is TL1, timer low, you have 2 timers, so to control it you will have 2 8-bit registers which are not bit addressable. These are bit addressable registers. So bit addressable registers, they have shown the bit addresses as well, so you can understand the way in which they have shown it. So the B register is bit addressable, accumulator is bit addressable, PSW is bit addressable, IP is bit addressable, P3 is again bit addressable, but this is not bit addressable. So this is a serial buffer which is not bit addressable. The TH1, TH0 timer high, timer this is for first timer, is for 0 timer, timer 0 and timer 1. We'll see in details when you try to understand what a timer is, which will later. But understand that inside your particular RAM memory, the 80 to FF values are used for special function registers. You have n number of special function registers inside your particular 8051, not n, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21 special function registers which are being used for various purposes, power control, then DPH and DPL, stack pointer, P0. So you have different different special function registers being used for different functionalities. giving different names. So according to the value, you have byte addressable values here and bit addressable values which are thrown internally. Okay. So if it's D0, D0 to D7 becomes bit addressable. E0, E0 to E7 becomes bit addressable. F0, F0 to F7 becomes bit addressable. So according to that, each of these bits will have an address. There are certain registers which are not bit addressable as well. Okay, so this is basically the set of P0. This is your port 0, port 1, port 2, port 3. So this is the basically set of special function registers which are available inside your particular 8051. So the two special function registers are being expanded here. The PSW 8-bit register, parity flag, overflow flag. This is basically to select the banks RS0 and RS1. 00 means bank 0, 01 means bank 1. So accordingly, you will have value here. F0 is an additional flag register which can be used, user flag, which can be used for your own purposes. Then auxiliary carry is the carry flag. So you have OV is overflow flag. So you have different flags and register set bit RS1 and RS0 to select the bank which is being used currently. Okay. Then you have your PCON, the power control register. 7th bit is used to control the serial mode. Different, we will see that again when you speak about serial combination, but this is basically to select the type of serial mode which is being used here. Then GF1 and GF2 global flag registers, GF1 and GF2. Then you have your PD and idle. PD is power down mode, idle is idle state. The difference here is in power down mode, as far as I am concerned, only the clock is switched off. Idle mode, everything is switched off. So you have two power control modes which are supported by your particular 8051, power down and idle. Power down is when most of the things are inactive. Idle is when nothing is active. Both can be taken out or moved out by using interrupt. From interrupt comes, both these will be moving out of these corresponding modes. This is basically used to save the power. So these are the two registers, PSW and PCON, used inside your 8051. So that is with respect to your memory organization. Now another thing, you have also a what say ROM memory. The ROM memory usually starts from, it's a 16-bit address location. So that means it has an option of starting from 000F to FFFF. That's your 16-bit value. But since you are using a 4K byte memory, it starts from 0000 to 0FFF. So that is how the memory is organized inside your ROM. So it has an address range and you can put the values of these things inside this. But when you speak about memory organization, the major chunk is explanation is with respect to your RAM. Now, one thing that is left in in your module 3 is your circuitry of IO ports, how the IO ports functions and what is the circuit inside your IO ports, which you will take in the next class. So try to comprehend it, not fully, but at least you should be able to understand that you have bit addressable locations, you have RAM memories, you have ROM memories which are being used as part of your 8051. And from the next module onwards, we will try to do programming as well. I'm going to use a simulator called as EDSIM51 mostly for doing the programming part. Module 3 is a very theoretical module, but it requires, I mean, if you understand this, you will get the basic concepts of microcontrollers. Okay, so that's it for today's class. Stop the recording 1 second.